Hi, I'm actually making a video here out of a couple of old videos. The website you may notice has changed a little bit and it's called MathXL instead of MyMathLab, but you'll notice that it's almost identical to our current website and the problems are the same as the ones you'll be working on.
And let's look at that very first homework set. You've got a couple of animations here you will have looked at. Let's open this up. You'll notice that I've already been working on this one. It's got a mark for one that's incorrect. You'll have a green check by problems you've already done correctly. Let me go in here to question 2, which I think is a good example of a distance problem, calculating a distance. And partly I want to help with the homework, but partly I want to just point out some of the quirks of MathXL while I'm at it. Okay, so find the distance between a couple of points, and the points are listed, and my answer is supposed to go down here. Notice up here that you can see you can navigate back and forth, or just go to the problems you have wrong to fix them, that kind of thing. And I also want you to notice that although this is number 2 problem in the homework set, look over here at this 1.1.35. That's the problem that this is based on in the textbook. And that's actually the one to refer to if you want to ask me or somebody in the Math Resource Center a question about a problem. If you tell them it's 1.1.35, they can find it in the book for you. Okay, let's do this problem. I want to point out that everybody should have a notebook for this class. Here's my here's a picture of my notebook. Nothing too special necessary here, but you should have a notebook that you're bringing to class and also using for homework. I've got my reasonable set of Monday notes here, or some of you may have met on Tuesday instead. And I think you should be taking notes in class. It doesn't have to be real detailed, but I have a little bit of stuff about the distance formula and the midpoint formula right here where I can refer to it when I'm doing homework. And then over here I want to mark homework set 1 is where I'm working, and here's a problem 1.1.35, right? That's how I should label the problem rather than problem number 2. And then have this available so that you can do work in this window just as you would if you were working on a standard homework problem. Here we go. So distance between these guys, I kind of copied out the distance formula. I've got the difference in the x-coordinates and the difference in the y-coordinates. And it doesn't matter which direction you go in, as long as you, when you subtract them, you'll get either a positive or negative number that disappears when you square the results. And I add those squares, and I get the square root of 45. Let's see, 2 minus negative 4, 6 minus 3, yeah. Okay, let's see what happens if I enter the square root of 45 in here. Notice it says type an exact answer using radicals as needed, and I use the radical symbol over here from my symbol palette. Let me check the answer. Oh, not correct. Although your answer is equal to the correct answer, it's not in the correct form. I failed to simplify. Of course, over here you can see the next step. MathXL didn't want radical 45. It wanted 3 times radical 5, which I got to by simplifying the radical. That's going to be a real issue with MathXL, is always making sure you get the exact answer in here and paying attention to what they say about the form the answer has to take. Kind of watch down here to see what the advice is. Check answer. Okay, fantastic. We're good on that one. And then I could go on to another problem. And I think the next one I'm going to look at with you is maybe number 6, a midpoint problem. But to keep these videos all under 5 minutes, I'm going to sign out and start another one on a midpoint example.
Never mind, maybe we can just get that one up right here.
Here's number 1.1.49. I think it's 4th or 5th on your homework assignment maybe.
Actually, this is
It's
not a
like number
midpoint
23
formula.
since I came in through the study plan. But even if you're good with the distance formula, this one might give you a little bit of trouble. It says plot each point and form the triangle ABC. Verify that the triangle ABC is a right triangle and find its area. Now I trust that you can plot these 3 points on a coordinate plane. I know you could probably by a process of elimination just check out the multiple choice here, but it wouldn't kill you to actually plot the points in your homework notebook. Now it looks like this could be a right triangle. If it is, probably side A and B are perpendicular with the right angle right in here at point 3, 5. Let's see. Looks like B is a reasonable graph in this case. And I'll check that answer. Okay. So now what do I do next? I'm supposed to verify that the triangle ABC is a right triangle. How the heck do you do that? Well, if you get stuck on these problems, don't forget your help lines over here. This one, if you hover over it, help me solve this, will actually take you through step by step and give you hints. Another thing that might be useful sometimes is just view an example. Let me go ahead and click that. And rather than have you do help you step by step, this will just show you an interactive example. So it says, here's another problem, same type, begin by plotting the points. And if I hit the continue button here, I'm going to see the successive points get plotted and then connected with the triangle. And when they say to show that the triangle is a right triangle, we want to demonstrate that the sum of the squares of the shorter two sides, here they are equal to the square of the longer side, the hypotenuse of the right triangle. I'm a little squished in my window here. If I hit and continue, they'll lead you through step by step and show you all of this stuff. You can also potentially print one of these examples and then use it to follow your own. Let's see, I'm going to get rid of this now. Close. If you follow that, let's see, here I am back here to my problem. I'm supposed to check the Pythagorean theorem. Here's my Pythagorean theorem. One version of it would be that this triangle with lengths of sides A, B, and C, this is a right triangle if and only if the sums of the squares, the sum of the squares of the shorter two sides, is equal to the square of the longest side, the side opposite the right angle. And then I'm supposed to find the area of a triangle in the later part of the problem. And here I've got, you'll notice some mislabeling on my triangle. Area is 1/2 base times height, where the base of the triangle, this should be B down here, is perpendicular to the height of the triangle. This should be labeled H. Okay, and I've got my work over here. So after drawing in that triangle, I'm finding length of A using my distance formula, and length of B using my distance formula. In both cases, if I do that carefully, I get square root 29 as the length of each of those legs of the triangle. And length C, applying the distance formula one more time, I get square root of 58. And sure enough, A squared plus B squared, that would be 29 plus 29, is equal to C squared, 58. So this is a right triangle. If I fill in sums of the squares of the lengths of the legs over here, that's going to be sums of the squares, 58. And if I fill in square of the length of the hypotenuse of the triangle, that was also 58. And finally, I'm supposed to, check my answers, good job. Then I'm supposed to find the area of the triangle. So using area equals 1/2 base times height, I get 29 halves. Let's see if I can enter that as a fraction. Cool. Okay, well, that's how you do that problem.
By the way, those notebooks will be collected a couple of times during the term, so you do definitely want to keep track of your work in a notebook as well as your class notes. And I will catch you next time.